Don't you wish you could grow up slower?
Yeah, I wish I could stay 16 for more than 1 year.
Only magic can do that.
Well, even though it's only theoretical now, it might not be magic. You see, if I take a pair of twins, they're the exact same age. I keep one on Earth and send one blasting off into space at a really high speed. When he returns, he'll be younger than the Earthbound one. To understand this, we need to understand something really important we learned through Michelson's experiments. Until 1905, it was believed that light needed a medium to travel through, like sound waves do, called ether. Until Einstein proposed that light needed no medium to travel through. You see, if ether did exist, the universe would have to be filled with it, as we can observe light from distant galaxies, and this would mean we would be moving through it, which means that light would travel at different speeds in different directions. To illustrate, a swimmer swimming downriver with the current will be faster than a swimmer going upriver against the current. The interferometer created by Albert Michelson helps us understand that this isn't true. It uses two perpendicular arms with mirrors at the end and a screen which detects the interference between them. As it was slowly rotated, there was no changes in the speed of light, proving that the speed of light, c, is constant, which means that me up here, me when I was down there, or even the birds flying across the sky would see and measure light at the same speed, telling us that the thing that changes for different observers at different speeds is not how fast a light beam appears to move, but how fast their clocks appear to run. Hence, the length of the rocket in the direction of motion seems shorter, and its clock seems to run slower. Both of these change by the same factor, g. G isn't significant at velocities we travel at every day, but becomes more prominent as we approach the speed of light. At 1c, g is infinity, which is where the equation E equals mc squared originates from. So, for our twin moving at a fraction of the speed of light, a clock with a photon bouncing between two mirrors, time seems to run slower, as the distance traveled by the photon is increased, while its speed, c, stays the same. This is the second postulate of Einstein's theory of special relativity, the other one being that the laws of physics are the same in all inertial reference frame, simply meaning stationary or at a constant velocity. Moving at a constant velocity with no acceleration, the laws of physics stay the same. Any measurements taken at this constant motion will be the same as on the ground. In fact, there's no experiment I can do right now to determine my velocity. I can only tell that I'm moving relative to something, such as the clouds. We often consider our Earth as a stationary reference frame, when in fact we're moving at 70,000 miles per hour around the Sun, and the Sun is moving at 500,000 miles per hour as it orbits the Milky Way, and we're moving at 800,000 miles per hour through cosmic microwave background radiation. We don't notice it as we're in inertial frames. This brings us back to why one twin is older. You might think because they were moving at a constant velocity of 0.5 c, they're still in an inertial frame. You might be correct if they never turned around and came back. However, as they turn, they accelerate, which means that they're no longer in an inertial reference frame. So, their space-time paths are no longer the same, which means the Earthbound twin is older.